the answers to exam 2. The first question talks about a sailboat with two forces acting on it. That's the north and the east, southwest direction. The first is an eastward force of 3000 Newton, and the second is a 6000 Newton force directed towards the northwest. And because the east force is already along the x-axis, there's nothing to be done to it, but the other force along the northwest is to be resolved into two components. That's the x component and the y component. Now, 3000 Newton, and you have 6000 newtons. Know that the angle is 45 degrees there. So when you resolve, this is 6000 cos 45. And the other is 6000 sine 45. Okay, now taking the net force along the x-axis, that's going to be 4242.6, which is 6000 cosine 45 minus 3000, because they are in opposite directions. And the net force along the y-axis is just 4200, 42.6 newtons, because there's only that y component. And therefore, when you take the vector sum, you got to add them up after squaring them and take the square root, which gives 4420. That is the force. Now, to find the angle, you take the net fx and the fy and look at that triangle, and you see that tan theta is opposite side is fy by fx. So you get 73.67 degrees north of west. Now, to find the acceleration, all you got to do is take the net force and divide by the mass. The mass is 2000 kilograms. So you get the answer as 2.21 meter per second squared. Now, this problem is important in the sense that excuse me, it teaches you, or rather shows you, how to resolve a vector and add the components and hence find the net vector. In question number 2, the conveyor belt obviously is not moving in a circle, because then the object goes nowhere. It's going straight ahead. Maybe it comes back after a lot of linear motion, but it's not a perfect circle. Of course, it has to return, but just like the luggage that comes over the conveyor belt in the airport, it has a lot of linear motion. So we're looking at the linear part moving at 2 meters per second. And when the box is dropped onto it, it is dropped from rest, and you see, as soon as it hits the conveyor belt, it'll begin to move at 2 meters per second. But then the final velocity between the box and the belt must be 0. So we're looking at the relative velocity between the box and the belt. And we have to find the coefficient of friction. So obviously you have to get the frictional force first, and the initial velocity is 2 meters per second. The final velocity is 0 meters per second. and that is when there is no slipping. So the forces acting are the weight acting down, mg, and the force of friction, which is given by mu times Fn. So mu Fn should be equal to mg. That's 0.3 times 9.8 times the mass. And so acceleration is friction by mass. Gives you 2.94 meter per second squared. Obviously the mass got cancelled. And now knowing the acceleration, initial velocity is 2 meter per second. Final velocity is 0, and we got to find the time. So use the equation V is equal to V naught plus AT. Rearrange to find time. Remember that the acceleration was a negative because it was actually slowing down. So when you take the two negatives, you see that you get a positive 0.68 seconds. In number 3, 0.6 joules is spent for each step for each kilogram. Now, since a person has a mass of 60 kilograms, the total energy is 36 joules for one step. Now, power is work over time, which means it's the amount of joules in 1 second. So 70 joules are used in 1 second. So divided by 36 joules per step. When you divide it, you see that the number is 1.94 and the unit would be steps per second. So that shows you how many steps it takes in a second. If you look carefully at the units, the joule and the joule will get cancelled. The step goes to the top and second down in the denominator. So now we know how many steps it takes in a second. And what is the length of each step is 1.5 meters. So if you multiply 1.94 with the length of each step, you would get the distance or displacement in 1 second, which is the speed or the velocity. So you get it as 2.91 meter per second. And number 4, you have to find the period of the satellite. Time period is given by that formula, which you can easily get by putting the centripetal force equal to the gravitational force, and you get that. Rearrange it, you get that. And now it's just a matter of substituting the numbers carefully. Remember that the actual distance is the radius plus the height. Everything should be in meters. That's what you get before you take the square root. And then on taking the square root of that, you get 8860 seconds, which divided by 3600, 2.46 hours. Question 5. This is an unusual spring because F is not equal to a constant times x. You can see that the function has a quadratic term in it, second power of x. So to find the work, you take the integral of f with x, because work is force times displacement. So when you integrate, you get 3x squared by 2 plus x cubed by 3 plus a constant of integration, which will get eliminated because when x is 0, you get the f as 0. So that's why I did not write it. So when x is 2 in that equation, you get 8.67 joules. And that should be the kinetic energy, because whatever the work is becomes the energy. So 8.67 is equal to 1/2 mass times velocity squared. Rearrange. And calculate. You get the speed of the mass, which will be the maximum speed when it returns to its equilibrium length. In number 6, the projectile is fired from a height. Again, when you use the conservation of energy, the angle does not matter. And that's what makes it easy. All you got to do is the potential plus kinetic energy at A must be equal to the potential plus kinetic energy at B. Now, potential energy is mgh, and we're talking about gravitational potential energy. That should be mgh1, and at B it will be mgh2 plus the kinetic energy. And we know that at B the object is almost at the ground, and so the height is 0. So the potential energy there becomes 0. Now that makes it easier. The masses have been cancelled out. That term becomes 0, and so gh1 plus 1/2 v1 squared is equal to gh2. That's cancelled out, so it's 1/2 v2 squared. And then if you multiply throughout by 2, the halves will get cancelled and you get a 2gh1. So therefore, v2 squared is that. And then take the sum of the two quantities and take the square root. You would get 156.4 meter per second. Makes that problem so easy. And in number 7, which is an important thing, I'm first drawing the diagram without considering friction. mg is the weight, Fn is the normal reaction. If that angle is theta, then you get this as Fn. Okay, that angle will also be theta from the geometry, so that will be Fn sine theta. That will be Fn cos theta, because that's the adjacent side. Okay, so we've not considered friction now. So if there's no friction, then you see that Fn sine theta is actually providing the centripetal force, because it's acting towards the center of the circle. And Fn cos theta is balancing the weight. So you have those two equations and divide one by the other. You get tan theta, because the Fn's cancel out. Tan theta is equal to v squared by rg. When you plug in the numbers there, you have to change kilometer per hour into meter per second. Get 19.44 meter per second. And put those numbers into this. You will get tan theta and then from tan theta you can find theta. It's 27.2 degrees. Okay, now what you have seen is the friction acting straight down the inclined plane, because friction is always tangential. And that tangential force is resolved into the vertical component, and the horizontal component is given by the dotted vectors. So that's friction, and that is going to be friction sine theta. Again, you got to be careful with the angles. And that is friction cos theta. So now with the friction, you see that you have to consider, when you look at the diagram carefully, you see that the centripetal force is actually provided by two. Now here you have Fn sine theta plus FFR cos theta, together providing the centripetal force. So there's more centripetal force, there's a greater chance for it to stay on the road. At the same time, Fn cos theta, looking in the vertical, minus FFR sine theta is equal to mg. Now all you got to do is just the mathematical steps of isolating the coefficient of friction. Now friction is mu Fn, so you substitute that and take out Fn common. Do the same in the second equation. And the first one, when you take Fn to one side, you get the whole thing divided by what transfers from the left side. Again, from the second one, becomes mg divided by that whole thing. So now you have two expressions for the normal reaction. And I'm going to put them equal to each other. So putting the two expressions equal to each other, the masses cancel out, and then now cross multiply. Distribute the terms. Collect the terms that have mu onto one side, that's the right side now. And be very careful about the signs and how they change. Take mu common from here, these two terms. And then to find mu, just divide the term on the left side by the term that you carry over from the right side. And to simplify this, you could substitute and calculate, but to simplify, divide each term by cos theta. The cos terms cancel, and where you have the sine, it becomes tan. Now when you are asked to work out this problem, you cannot cram the final equation, you need to derive it each time. And then plug in the numbers and calculate. This becomes a very important question because you have to know how to resolve vectors. You have an idea of friction here, and you have to have the idea of a centripetal force. So everything is kind of tied into this. Banking comes in, and so that's why it becomes a very important question. Going on to 8, you have 4 spheres, and you are asked to find the force on one of them. I've called them 1, 2, 3, 4. And as you can see, the force on 3 due to 2 and the force on 3 due to 4 are equal. And then you have the force on 3 due to 1, which would be slightly less because the distance from 1 to 3, or rather from 3 to 1, is bigger. Now, since F32 is along the y-axis, F34 is along the x-axis, all you have to do is resolve F31 into its 2 components, which is given by the dotted vectors, and then you add those components to the forces already on the x and the y to get the total Fx and the total Fy, which are obviously going to be equal. So that's the idea. So F31y, and you have F31x components there. So let's do that. F32 is equal to F34 because the masses and the distances are equal and given by this formula. So five times 5, 25, and then the r squared gives you 100 g, which is the gravitational constant, which you do not want to plug in until the end. And R31 is square root 2 times the length of the square, 0.71. Therefore, now we can find F31. Same formula, gravitation, but the distance is changed, so it's 0.71 squared. That gives you a smaller number, that's 49.6 g. Now when you resolve, one is going to be cos 45, the other is going to be sin 45, but cos 45 and sin 45 are equal, so I just put them as cos 45. So you get it as 35g. Now, so to find the total Fx, now you see that you've got to add the 100g with the 35g. The same thing happens on the Fy. So you get 135g for both net force along x and net force along y. And now to find the magnitude of the total force, you get 1.28 times 10 to the negative 8 Newton. Obviously the direction is at 45 degrees to north of west, or even west of north, because it's at 45 degrees. Okay. And in number 9, you're asked to calculate the centripetal acceleration. Centripetal acceleration. So you have centripetal acceleration given by v squared by r. But v is r times omega. Remember, omega is angular speed. But also omega is 2 pi times the frequency, because in one rotation the angle covered is 2 pi radians. And frequency is just how many rotations in a second. So if you multiply that, you will get the total angle in a second, which is angular speed. So when you substitute all that, and then for omega, remember everything is squared, so 4 pi squared, f squared. Substitute the numbers. Get 38.68 meter per second squared. Now on to the 10th and the last question. That's the flatbed truck. That's the crate. The forces Its weight mg acting vertically down, the normal reaction, friction trying to keep it from running into the cab. Okay. Normal reaction is equal to the weight. Friction is mu times the normal reaction. So friction is mu mg, and the net force by Newton's second law should be equal to mass times acceleration. So put them equal. Mu mg is mass times acceleration, and so A is mu g. And you get 7.35 meter per second squared as the answer. So I hope you will study all these questions very carefully, trying to understand each step. Thank you and good luck.